Hey guys, today we're going to be looking at indices with fractional bases. But first, have a go at these recall questions in the back of your book and pause here so you can get the answers. In 3, 2, 1. The first one, we've got 4 over d squared. 4d to the power of negative 2 would have got you the same thing, but we wanted positive indices, so 4 over d squared. This one, 4 over x squared. Now, only the x has the negative 2, not the 4. That's why it's the only thing down the bottom. The next one, we've got 25m to the power of 5. Remember, we add the indices. Here, everything in the brackets is to the power of 0, so equals 1. And lastly, 5 divided by 10 gives us a half. And then 0 take away 3 gives us negative 3, which puts our f to the power of 3 down the bottom. That's a little bit of a tricky one, but I reckon you can do it. All right, we're going to do a little bit of an investigation. So if I have half squared, what that actually means is a half times a half. Now, when we multiply fractions, we do the numerators together and the denominators together. So 1 times 1 over 2 times 2, which equals 1 over 4. Now, just have a little think about that while we look at the second test. Here we have 2 over 3 to the power of 3. So that's 2 over 3 times itself 3 times. We can times the numerators together and the denominators together, which gives us 8 over 27. Now, if we have a look at this 1 times 1 over 2 times 2 and our original half to the power of 2, can we see that 1 times 1 is just 1 squared and 2 times 2 is 2 squared? Let's have a look at this one over here. 2 times 2 times 2 is 2 cubed, and 3 times 3 times 3 is 3 cubed. Do we notice a pattern? I hope so. It turns out that our rule is that for any base, which is just the big number that's being multiplied, to the power of any number, means that everything in the brackets, or the numerator and the denominator, both get that power. So let's have a look at what that would look like in an example. So here, our first example, we've got a quarter squared. That's the same as 1 over 4 squared. So our 1 also has a little squared up the top, but 1 times 1 is just 1. Now, if we wanted it in index form, we'd leave it as 1 over 4 squared. If we wanted it fully expanded, we'd go 1 over 16. And that's the same for 1 over a to the power of anything. Our 1 gets to the power of 5 and our a gets to the power of 5. Here, 3b over 4 squared, everything in the bracket, so every part of the numerator. So the 3 gets squared and the b gets squared, as well as the 4. Now, 3 squared is 9 and 4 squared is 16, so we can further simplify that to 9b squared over 16. Lastly, I think you had a look at some of these yesterday. This is when we've got a negative index, 5 over 6. Our 5 gets the negative 1 and our 6 gets the negative 1, which means that we flip both of them upside down, which is pretty cool. All right, have a go at the practice questions and ask me if you need any help.